Hello students. So again we are going to solve one more question of IT JAM 2021, and this is a MCQ 2 mark question, 2 marks question, and this is from the moment of inertia chapter. So it's a quite simple problem, but yes, it is little bit more conceptual. So there is a disk, and suppose this is my disk, but this disk has mass density, that is obviously this mass is distributed into 2 dimensions. So I can assume this is my x-axis, this is my y-axis, and this is my z-axis. Perpendicular to this particular plane is my z-axis. And the mass density is given by something like sigma naught 1 minus r small r square by capital R square, where capital R is the radius of disk. So we have to calculate the moment of inertia about axis passing through uh, about z axis which is passing through center. So we have to calculate the moment of inertia about this axis. So I can just make it arrow, just cross, such that we can assume that axis is passing perpendicular to this one. So obviously we can use this particular concept. So I, at some distance r, I can take a small mass element. Let's say this element is nothing but dm, and we are just taking this distance is r, and this can we make some angle theta, and if you want you can take something like this. So this is basically angle d theta. This is at distance r. So this is my small element of mass dm at distance r. So what we have to do, we have to calculate the moment of inertia. So if we are able to calculate the moment of inertia due to this small mass dm, and we can integrate throughout the region, then obviously we can solve the problem. So obviously the moment of inertia about z axis iz is equal to r square into dm. The most important task is that we have to write dm as a function of sigma r. So what is sigma r? The sigma r is nothing but this is dm upon dA. And this, I can write this dA in a circular symmetry. So this dm by dA can we write r dr d theta. So this elemental area, if I will put this angle as d theta, this is r, this distance is dr, then obviously this is r dr d theta, the whole area. And we can easily derive this particular thing also, but I am not going to derive it. So what I can get my dm is equal to sigma r dr d theta here, and we can put this particular value here. Now we have to go for the double integral. So we have to put the value of sigma r. So when we are going to put the value of double integral, this is r square, and sigma r is nothing but sigma naught 1 minus r square upon capital R square. But my variable is dr as well as d theta, and here we have to go r dr d theta. So we can easily take this particular thing, and now this r will go to 0 to capital R, and this theta will go to 0 to 2 pi, because we have to move for whole particular angle, this angle 2 pi, such that we can cover the whole area. And when we are going to integrate it, this is very simple integration. D theta will go to 0 to 2 pi, so I can go take 2 pi outside, and sigma naught will also outside. So I am just going to integrate it. So sigma naught 2 pi sigma naught is there, and only integration is there. We have r square minus, and there is one more r is there, so this will be actually r cube, and here we have r to the power 5 upon r square, and we have to go for dr 0 to capital R. And when we are going to integrate it, we have to be little bit careful. So this value is 2 pi sigma naught, and I can do it here just because I can do it here. So this value is 2 pi sigma naught, and that value is equal to R4 upon 4, and here is, I think, R6 upon 6 R square. So obviously this will be R4, the dimension of this is R4. So yes, both have same dimension. It's a good sign. So we can just write this particular thing as, so I am writing here, or you can use this space also. So we can use this space. So this value is basically 2 pi sigma naught, and we have R4 by 4 minus R4 by 6. And when we are going to calculate this particular thing, I can take 12 here, and we have, so this will be 2 pi sigma naught, and we have R4 upon 12, and this is equal to pi sigma naught R4 upon 6. So the answer of this moment of inertia, Iz, is equal to pi sigma naught R4 by 6. Obviously, this problem is very simple problem if you understand that how you can write dm as function of r and theta. But in the examination, when we are doing this integration, you have to be a little bit careful, because all options are so close and so deviating that sometime once you will do some little error, you will trapped into that into examiner trap. Okay, so I think the answer is basically pi sigma naught R4 by 6 is the answer. Okay, thank you.